Hello everyone, so I'm back with another video. I know I haven't been posting any videos for the last few days, I guess a week. That's because I have my exams going on right now and it's going to end the day after tomorrow. So today I am making this video because it's a free day for me, okay? And I won't be posting for another 2 days, that is tomorrow and the day after tomorrow. And then I will be back. So that's only because I need to give these exams a little bit of time, otherwise I might screw up, right? So I hope you understood. So let's see the problem. It's something we know already. Binary search. Given an array of integer nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with big O of log n runtime complexity. Okay, so it's pretty much clear that even if the question statement didn't say binary search, it should be clear with this one. We need to search our arrays in sorted in ascending order, okay, and our time complexity should be big O of log n. So it's pretty clear. We are going to use binary search. So what do we do in binary search? As we already know, I have solved quite a bit of problems. If you see my playlist, you will see that we have solved few problems of binary search. Okay, but this is the very basic problem. Okay, implementation of this algorithm. Okay, so what do? We put a low pointer at the beginning and a high pointer at the end, start or end, whatever you want to call it. Then we compute the mid position. Now what is the mid? The mid is 0 plus 6 by 2, that is 3. So this is our mid position. Okay, now we will see, let's say our target is 3. Okay, we want to see if 3 exists in our array or not. Okay, so we'll see, we will compare this mid element with our target. So we see that this 4 is greater than 3, right? This 4 is greater than 3 and we know our array is sorted. So if this element is greater than our target, that means the target will lie this side, isn't it? The target will lie this side. So there is no point in searching our element in this side, isn't it? So we will discard this side. We will discard this side. And what we will do, we will move our high pointer to here. Okay, that is one position, just one position before our mid. Okay, then what we will do, we will compute our new mid. So what is our new mid? 2 plus 0 by 2, that is index 1. This is our new mid. Okay, now we will see if this middle element, if it is greater or smaller than our target. We see that it's smaller than target, right? So our array is sorted, right? And if our middle element is smaller, then that means the target will lie to this side, isn't it? This half. So there is no point in searching in this side, isn't it? So what we will do, we will move our low pointer to mid plus 1. Okay, now our low is here. Then again, as usual, we will compute our mid. So this is our new mid now. 2 plus 2 by 2, that is 2. Now we will see, compare. If this element is greater or smaller or equal, we see that this element is equal to our target, right? That means we have found our element. So in that case, just return the index, that is return mid. Now let's say we want to find 4, okay, a number which does not exist in our array. Okay, so in that case we need to return -1, right? So let's see how this binary search is going to work in that case. So as usual, keep a low and keep a high here, right? Calculate mid. Okay, fine. Is this element greater or smaller? It's greater, clearly. That means our target might potentially lie in this side, right? So discard this side. Okay, so our high comes here. Okay, fine. Now calculate the new mid. This mid is gone, useless. Okay, now the current element is smaller than our target, right? That means our target will potentially lie to the right of our mid, isn't it? So move our low to mid plus 1, right? It comes here. Now we calculate the new mid. What is it? It's the same position, 2 plus 2 by 2. Okay, now we'll see 3 is smaller than 4, right? Our target. That means our element will lie this side. Okay, in that case, what we will do, we'll move low to mid plus 1. Okay, now we have hit a condition, a base condition type of thing, that our low has exceeded high. Low has become greater and high has become smaller. That means they came from both sides to each other and crossed each other, but still wasn't able to find the element. That means our element does not exist. Whenever these high and low exceed each other, cross each other, right away return -1. Okay, break the loop. Okay, whatever you were doing. Okay, so this is the algorithm. It's pretty simple. Now let's look at the code. Okay, so let's start. What are we going to need? Initially, we are going to need our low pointer that will stand at the 0th position and a high pointer which will lie at the last position, that is nums.length -1. Okay, now while our low is less than equals to high, that means while they haven't exceeded each other, do something. Do what? Calculate the mid. mid equals to low plus high minus low by 2. Why not low plus high by 2? Because let's say our low is a very big number, as well as high is also a very big number. Okay, so there is a possible chance that it will cause an integer overflow. Okay, so in order to prevent that, we do this. Okay, I have discussed this thing already. Okay, so first we will check if the target that we have been given, is it equal to the element at the mid position. If it is, then return the index. That is the mid, isn't it? Mid pointer. Otherwise, if that is not the case, okay, we'll check two conditions. If target is less than nums of mid, okay, and target is greater than nums of mid, okay, that is else. Okay. Now let's see. This is our target. Let's say if our target is less than mid, what we will do? We'll move our high to the left position, right? That is high equals to mid minus 1, right? And if our target is greater than our middle element, what we will do? We'll move to the right, right? Isn't it? We will discard the left side by doing low equals to mid plus 1. We'll move the low, isn't it? Mid plus 1. Okay, so this is the algorithm, and it will, what it will do, it will make this low as well as high both come to each other until they find our target. And if they don't, they will cross each other, right? They will break this condition, and as soon as this condition is broken, we will move out of this while loop. And if we move out of this while loop, we know that the element was not found, so in that case return minus 1. Okay, so this is the code. Let's run it. Let's submit. There we go. So this is the solution. There exists a recursive solution for binary search as well. That is also pretty easy. Okay, so if you want to check that out, you can definitely check that out in the internet. Okay, but this is the pretty standard solution, the algorithm which you are going to need many a times. Okay, the time complexity is of course a big of log n, right? So yeah, this is the solution. I hope you liked this video. If you liked it, do hit the like button, share this video and subscribe to my channel, and I will see you in the next one. Bye bye.